Alright, hello class. Today we're going to be talking about lesson 7, which is on quadratic equations. Quadratic equations are of this type, where you have ax squared plus bx plus c is equal to 0. So we're taking a step past what we looked at last time, or last week, which was linear equations, where all we had was up to the x. Okay, so now we're trying to look at equations all the way up to x squared. Here's the trick with these. You can solve all of these with the quadratic formula. Okay, if you remember the quadratic formula, right, that's if you had an equation like this, ax squared plus bx plus c is equal to 0. X is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, now this is likely something you've seen in your algebra classes from, the very first time you ever laid eyes on an x squared type equation. So this will always work. That's the nice thing about quadratic equations, is you can always set up and use the quadratic formula, but it's not necessarily all that pretty, right? So what we're going to be looking at here, we'll look at a couple examples where we actually use the quadratic formula, but what we really want to talk about is how do we avoid using the quadratic formula, right? Are there techniques we can use where we don't have to? And not just because we don't want to use it, but because those techniques are also going to be faster, right? They're going to save us time. And hopefully will give us fewer places to make mistakes, like we have here, where there's lots of little places where we can make mistakes. All right, so let's talk about our first technique. Okay, the first one I'm going to talk about is what is called the square root method, or the square root property. Basically, if you have that x squared is equal to some number, I use the letter n for number, then x is both plus or minus the square root of that number. All right, and here's the same method just with an actual number. So if x squared is equal to 4, okay, you don't just take the square root of both sides. I know a lot of people like to say that. You take the square root of both sides. You don't actually do that. X is going to be plus or minus the square root of the number. All right, so this is going to be plus or minus 2. All right, now on MyLabs Plus and other places, you're not guaranteed to have a plus or minus. Okay, so what you're going to be doing instead is they'll give you, the whole solution set thing that we did before, right? Solution set, and you'll do -2, comma, +2. Okay, or +2, comma, -2. Be real careful about what it actually asks you. I think some of you had some issues with a homework before where it told you to write all your answers in ascending order. So be sure you're careful about what it's actually asking for and asking you to do. Okay. Now the reason it's both plus or minus is because if we go back to check our work, if I plug in 2 into this equation, so I'll have 2 squared is equal to 4, right? But then also if I plug in -2, square it, it also equals 4, since squaring something will cancel out the negative. Okay, so that's why both positive and -2 are solutions to this equation. So that's, I tell you, that's one of the biggest mistakes I see, always, forever, all the time, is people forgetting that with a quadratic, the solution is both plus or minus the square root of that number. All right, so as another example, let's have 3x squared is equal to 12. Okay, so this one's a little different because it's not just x squared is equal to a constant. So if you have something that looks like this, get it that way first. So remember, the property is given as x squared equal to a number. Well, we don't have that. We have 3x squared. Right? So just divide both sides by 3. So you get x squared is equal to 4. Once again, and this tells us that x is equal to plus or minus 2. So when we go to do our solution set, we could say it's negative 2. Okay. So if you have a constant out front of your x squared or something like that, go ahead and solve it. I'm using quotes here. Solve it for the x squared, then use the square root property. Alright, this method will work if you have something else than just x squared. So if you have some stuff squared is equal to a number, this will still work. So for example, if you have this equation, okay, where we have x plus 1 all squared minus 3 is equal to 33, well, you could start, alright, by multiplying this all out and factoring or doing some other stuff. Or if I move this over, that's this 3 over to start with. Okay, I'll get that x plus 1 all squared is equal to 36. And now I have stuff squared. Okay, so if it's true for x, it's going to be true for anything else I use this property for. So I have some stuff squared is equal to 36. So that stuff, I'm just going to cover it up for now, is going to be equal to plus or minus the square root of 36. Okay, so that stuff was x plus 1. So x plus 1 is going to be plus or minus the square root of 36, which will be plus or minus 6. Okay. So what that tells me is now I have this new equation, x plus 1 is equal to plus or minus 6. And if I move that 1 over, I'll get that x, so subtract 1 on both sides, I'll get that x is equal to negative 1 plus or minus 6. Okay? So, in other words, it doesn't have to just be x. It could be all sorts of things. Okay, just some x plus 2, x plus 3. If it's all squared and all you have are constants, you can get it down to a something squared is equal to a number and apply your square root property that way. Okay. Now, when you go to put in your answer, like I said before, you won't, necessarily have a plus or minus button or what have you. So you'll do an x, like a negative 1, x equals a negative 1 plus 6, and x equals negative 1 minus 6. Okay, so your solution set is going to be, this will be 5 comma negative 7. Okay, here's another equation like this. I have 4 times x plus 9 all squared is equal to 36. So in cases like this, and again, the thing you're looking for is the stuff squared, and everything else is numbers. Okay, there's your identification for what methods you want to use. Again, the other methods we'll look at, you could also do, you would just have to expand this all out, use the quadratic formula or factor or something like that. But here, what I'll do, I'll start by dividing both sides by 4, and I'll get that x plus 9 all squared is equal to 9. All right. Then from the square root property, since I have some stuff squared is equal to 9, okay, that's going to give me that x plus 9, that stuff is going to be plus or minus the square root of that number 9. Okay, So all I need to do now is move that 9 over. And if that was a minus 9, you'd get a positive 9 on this side. But we'll have negative 9 plus or minus the square root of 9, which is 3. So when we do our solution set over here, I'll do a 9 plus 3 and 9 minus 3, just off to the side to get my numbers. This will be a negative 6 and a negative 12. Okay, so negative 6 and negative 12 are my solutions there. Okay, so that's the square root property. If you ever have something squared is equal to a number, or you can easily get it down to just being that, right, then you can use the square root method. A common answer or a common question might also be, what happens if you have something like x minus 1 is squared is equal to 3? Something where you don't get a nice square root, right? So here you get x minus 1 is equal to plus or minus the square root of 3. You can move the 1 over to get your answer is 1 plus or minus square root 3. Well, in this case, let me break this off. Your solution set is really just going to be 1 minus square root 3, 1 plus square root 3. Okay, you can leave your answer with the square roots like that. You don't have to put decimals. And again, look at what your MyLabs Plus is actually asking you to do, because I'm looking at one right now off on my laptop here that says type an exact answer using radicals as needed, and use comma to separate answers as needed. Simplify your answer. So here, that's exactly what it would be asking for with the exact answer using radicals as needed. That's going to be 1 minus square root 3, comma 1 plus square root 3. Okay? But the nice thing about these, you might think they look bad, but there's no extra work to do. You don't have to calculate what those values are. You don't have to do this sum or difference. You just put it in as it was given to you, and there you go. That's that. All right, the next method to talk about is factoring, and this is the one I think most people are completely familiar with. This is where you're just going to factor the equation, okay? And it comes from the fact of what we call the zero product principle, that if two things multiply together to give you 0, then that means one of them must be 0 or the other one must be 0. So that's how this works. If we can factor the quadratic, we'll have it as multiplying by two pieces. And so if they multiply together to both give us, or to give us 0, that means one of them must be 0. Okay? So let's look at an example of this. Okay, let's say we have this equation here, that x squared plus 2x is equal to 8. All right, so for this equation, you'll notice, first of all, the difference that we didn't have before is we have this 2x here, right? So this is as x squared plus 2x is equal to 8. Now, I want to do this off to the side, because here's a mistaken way you'll see some people do this. I see this all the time. They'll factor this side. They'll just factor out the x. They'll say, oh, x is equal to x, or I factor out x. I'll get x times x plus 2 is equal to 8. So x is equal to 8, and x plus 2 is equal to 8, and I'm just going to stop you right there. This property we have specifically only works if you have two things multiplying together to give you 0. So if you're going to factor, okay, go back to the form we started with. You always want an ax squared plus bx plus c is equal to 0. Right? You always want 0 on your right-hand side if you're going to factor. Okay? In fact, any other method you do, other than the square root method, the square root method is the only one where you have something squared is equal to a number. Every other method, you want everything on one side, 0 on the other. Okay, very important there. All right, so let's do that. Let's move this 8 over. So we'll subtract 8 on both sides. We'll get that x squared plus 2x minus 8 is equal to 0. Alright, so now we're almost in business. Right now, we just need to factor this. So we want factors of negative 8 that sum up to be 2. Okay, so thinking about the factors of negative 8, if it's going to be 2, we know the greater factor needs to be positive. So I'm thinking 4 and negative 2, right? 4 times negative 2 will be negative 8. 4 minus 2 is 2. So this will factor in to x plus 4 times x minus 2. Okay, once we get here, then we can use the zero product principle, right? Because if two things multiply together to give us 0, which is what we have here, we have x plus 4 and x minus 2 multiply together to give us 0. That means one of them is 0, or the other one is 0. So x plus 4 is equal to 0, or x minus 2 is equal to 0. So x is either equal to negative 4, or it's equal to positive 2. If we move those over, right? You move the 4 over and the 2 over. Okay. When you get it down to stuff like this, it's actually you can speed up the process a little bit. You see that x plus 4 here will always give us a negative 4, and x minus 2 will always give us a positive 2. Okay, so that is a first example of factoring. Let's look at another one. All right, let's look at another example. Let's say we have negative 10x minus 16 is equal to x squared. All right, so the trick here, again, if you have all three pieces, your best bet is to get everything on one side and a 0 on the other. So I think the natural thing to do would be to move the x squared over, which would give you a negative x squared, a negative 10x, and negative 16, which would be dealing with a lot of negatives all at once. So here's a trick. We can instead move these pieces over to here and have the 0 on the other side. It doesn't really matter where your 0 is. You can still factor, you can still solve like normal. You could even rewrite it to have it the way you want. But basically, I'm going to move this 10x and this 16 over. Okay, to get that 0, because these will now cancel, is equal to x squared plus 10x plus 16. Okay, now we're going to try and factor this. I want factors of 16 that will sum up to be 10. So factors of 16, well, there's 4 and 4. Those come out to be 8. That's not going to be it. There's 2 and 8, so 2 times 8 is 16, and 2 plus 8 is 10. So that's that. We're going to get now x plus 2 times x plus 8. Okay, so if we go through the zero product principle completely explicitly, we'll now have that x plus 2 is equal to 0, or x plus 8 is equal to 0. So x is either equal to negative 2 or negative 8. Okay, now remember, when you list this in your on your MyLabs Plus, it's probably going to put it in little brackets for you to fill in. Alright, and there you go. And like I said before, once you get to here, you can kind of start to quickly see what you'll be going to, because an x plus 2 here will give you an x is equal to negative 2 here, and an x plus 8 here will give you negative 8 there. Okay, next up we have something like this. 25x squared minus 15x is equal to 0. Alright. There's a really tempting thing to do here, and that would be to move the 15x over and start dividing by x's and things. I suggest you resist that temptation. Okay? It's very easy to do that incorrectly and miss something very important. Okay? What we're going to do instead is factor. So we looked at two versions where we had an x squared plus bx plus c factoring form. What we're going to look at now is a different factoring form, because there's lots of ways to factor, as we saw. We had a whole section on it. We spent about 50 minutes talking about it, and it's not always the, that x squared plus bx plus c method. Okay, so in this method, all we need to do is a greatest common factor, right? Because we have common factors here. They both share a 5, okay, and an x. We can take an x and a 5 out of both. So if we take a 5 and an x out, we'll be left with here a 5x, okay, and here a minus 3. So what we're left with is 5x times 5x minus 3 is equal to 0. All right, so now we use the zero product principle, which tells us that 5x is equal to 0, or that 5x minus 3 is equal to 0. Okay, and now we're almost there. We divide by 5 on both sides here to get that x is equal to 0. And then here, I'm going to move the 3 over to get 5x is equal to 3, and then divide both sides by 5 again to get that x is equal to 3/5. Okay, so the solution set is going to be 0, 3/5. So the factoring method doesn't always give you a whole number, right? You can get things like this, a 3/5. All right, and there we go. What I wanted to mention before, as I said, the reason you don't want to do the method I talked about, right? Don't do this. If you move that 15x over and get 25x squared is equal to 15x, and you start like dividing, you divide by 5x on both sides, what you end up with is on this side you get 5x, and on this side you get 3, and when you divide by 5 you get 3/5. So you get one of your solutions, but check it out, 0 was another one. So this method is not reliable, and as we go along, it's actually going to cause a lot of problems if we try it this way. So pretty much, unless you have, and actually it's kind of true with linear equations too, but what you want to do is always, unless you have a very specific method you're doing, if you're trying to factor or you're just trying to solve pretty much anything, oftentimes your best bet is to get everything else on one side, 0 on the other, then try and factor. Okay, we will see this method pop up time and time again. Alright, let's look at this next example. We're going to try this with factoring. This is going to be that last bit of factoring we talked about, that AC method. So remember, the first thing we want to do, always move that 3 over so we have everything all on one side. Okay. Alright, so we get 5x squared plus 14x minus 3 is equal to 0. Okay, so if you remember the method for this, it wasn't too long ago when we talked about it. It's the AC method. So we're going to multiply our A and our C, which is going to be negative 15. And so now I want to find factors of negative 15 that sum up to be 14. Well, that actually isn't that bad. 14 is going to be 15 minus 1, right? And 15 times negative 1 gives us 15. So two things that will multiply to give us negative 15, 15 and negative 1, and will sum up to give us 14. Now, remember, in this particular type of factoring, when it's the AC method, we don't just put them in parentheses, we split it up. So 14x, I'm going to split up as 15x minus 1x, or just x. Okay, so we'll do that over here. I'll have 5x squared, and then my 14x is going to be split into 15x minus x minus 3, okay, is equal to 0. And if you remember, once we have it split into the 4 pieces like this, we factor by grouping. Okay, so I'm going to group these into 2 pieces and then factor each group. So this first group, I can take out a 5x. So let's do that. And here I'll be left with an x plus 3. And here, the only thing I can really take out is a negative. So I'll take out a negative 1. And then I'll get x plus 3. So remember, when you factor out a negative, you change the sign on both. Okay, don't try and solve yet. All right, this is a big problem I see often, is students will now start, I don't know, setting things equal to 0, doing all sorts of weird stuff. Remember, we need to finish factoring. So now these pieces both share an x plus 3, so we'll factor them out and get an x plus 3 times a 5x minus 1 is equal to 0. Alright. Now, we're going to use our zero product principle, and that's what this is all about. Okay, so I'm going to get that x plus 3 is equal to 0, or that 5x minus 1 is equal to 0. Alright, so x plus 3, I'm going to get that x is equal to negative 3. And here, I'll get 5x is equal to 1. Dividing both sides, I get that x is equal to 1 over 5. So my solution set here is negative 3, 1/5. Okay, and that's that. So if you remember your AC method, you can actually factor this one. And remember, we have to do that whenever we have a constant other than 1 out front from the beginning. Okay, now what if you don't remember this factoring method, right? This is one I find that people tend to forget. They look at this after they move things and they think, well, I don't remember how to do that. I don't know how to factor that. Well, remember what I said at the beginning. All of these can be done by using the quadratic formula. Okay, so let's say once again I have the same problem. We're going to do it a different way just to show you it doesn't matter if you factor or you use the quadratic formula. So I've had students that always use a quadratic formula. They don't want to think about factoring. They don't want to get creative. They just want to solve the dang equation, right? And so they just always use the quadratic formula. Now, here's the thing. Quadratic formula takes longer than these other methods, but you may disagree with that with the factoring method we just did, right? The AC method takes a little while. So the quadratic formula might actually be the better way to do it if you prefer it with a problem like this. Okay, so let's do this with the quadratic formula. Now remember, with the quadratic formula, you have to have it in the form ax squared plus bx plus c for this to work. Okay, so first let's move that 3 over again. So as you see, no matter what method we decide to use, we still start by moving that 3 over. Okay, getting everything all on one side, 0 on the other. Okay, so now the quadratic formula is this. If you have ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so we're just going to identify our pieces, plug in our pieces, and do all that fun stuff. Okay, so 5 is going to be our A, 14 will be our B, and negative 3 will be our C. Here's the thing to keep in mind. Little focus. Notice X is out here, just numbers are in here, just the A's, the B's, the C's, not X's. You're not putting X's in this. All right, I see some students mistake that, put x's in the quadratic formula and make a big mess. Don't do that. We're just putting numbers in the quadratic formula. Okay? All right, so it'll be negative b, which is going to be negative 14, plus or minus the square root of b squared, so that'll be 14 squared, minus 4, that is always a 4, ac, so a is 5, c is negative 3. Okay, all over 2a. Okay, I put this in explicitly, completely, so you see where everything came from, where everything goes. All right. So the first thing, 14 squared, that might not be one that you dealt with on, a normal basis. So I'll go ahead and give that to you. So we have negative 14 plus or minus 14 squared, which I did on my calculator here. 14 squared is 196. Minus 4 times 5 times negative 3 comes out to actually be a positive 60. Okay. All right, because we have this negative, positive, negative, those negatives cancel, and we get a positive. Okay, so what we end up with is negative 14 plus or minus the square root of 196 plus 60 all over 2a. Our a is 5, so we're going to get all over 10. Whew. Okay, now let's continue. All right, we just need to simplify this a little bit. This is going to be negative 14 plus or minus the square root of 256 all over 10. All right. Now, 256, that looks like a familiar square root. In fact, it is. When you put that in your calculator, here I'll show you. If you do square root of 256, you can see that there. Square root of 256 comes out to be 16. All right. So what we end up with is negative 14 plus or minus 16 all over 10. Okay? So that means x, I'm going to go back here, x is going to be negative 14 plus 16 all over 10, or it's going to be negative 14 minus 16 all over 10. Okay? So let's see what we have here. Negative 14 plus 16 is going to be 2. So that's 2 over 10. And then negative 14 minus 16 over 10, that will be negative 30 over 10. Okay? So 2 over 10, when we simplify that, is 1/5. Negative 30 over 10 is going to be negative 3. And I believe that's the same values we got before. Okay, I had to find it to show you, but yeah, when we did the problem by factoring, we got negative 3 and 1/5 as our solutions, and here using the quadratic formula we got negative 3 or 1/5 as our solutions. Now, which method is best? That's going to be up to you. Okay. When I can factor, I always prefer to, but for problems like this one where you're going to be using that AC method, you might be applying the law of conservation of misery, where it doesn't really matter which method you apply. It's just going to be the same amount of work no matter what. Okay, so let's look at another example using the quadratic formula just to get you some more practice seeing it. Alright, let's look at x squared plus 9x plus 4. Alright, this looks like it should factor. It kind of does, right? We would want factors of 4. That would sum up to be 9. Well, the only factors of 4 are 4 and 1, and 2 and 2. So 4 plus 1 would be 5, 2 plus 2 would be 4. Neither of those equal 9, so it's not going to factor. Okay, so what we'll do is use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so now you're noticing I'm writing this every time I use it. That, ladies and gentlemen, is my secret to memorizing things. Okay? Basically, the first time I ever had to do this stuff, I just wrote it down every single time. Every single time I had to use it, I just wrote it. Instead of just looking it up every time, I actually wrote the formula every single time. And eventually, I could write the formula without looking at it. And then suddenly, what do you know? I have it memorized, and I'll probably know it until I die. Right? Even when I'm done teaching and I'm on my deathbed, I'll still know the quadratic formula because I've written it about 1 billion times. Okay? So that is always my advice for students who are learning stuff. If you don't know a formula, and just write it every single time you have to use it. You won't have to try to memorize it. It'll just be there. So anyway, our negative b. Well, when we set this up, our a is going to be 1, since that's a number in front of x squared. B will be 9. And then our c will be 4. So remember not to put the x's in your quadratic formula stuff. So this will be negative 9 plus or minus the square root of 9 squared minus 4ac. So a is 1, c is 4. Okay, all over 2a. I always like it when a is 1 because it just makes things nicer. In fact, I like it when just about anything is 1. Okay, so we get negative 9 plus or minus the square root of 9 squared, which is 81, minus 4 times 1 times 4, which is 16, all over 2. Okay, so let's see, 81 minus 16 is 65. So we get negative 9 plus or minus the square root of 65 all over 2. And I don't think this comes out to be very nice. Yeah, I think that just stays as the square root of 65. Okay, so when we do our solution set, it's going to be, well, it'll be negative 9 plus the square root of 65 over 2, comma, then also negative 9 minus the square root of 65 over 2. Okay. And there we go. That's how we work the quadratic formula. Alright, let's do another example, and I want to just do this one to show some of the things that can come about when we do this. At the start, this looks kind of messy, right? We've got a 4x squared, got a 36. If we were to do the AC method, 4 times 36 is 144, so we'd be looking for factors of 144 that sum up to be negative 24. Or, if we didn't want to do that, we would be doing a quadratic formula with our b as 24 and our c is 36. So if you try to do this with a quadratic formula, it's going to focus. Okay, so with a quadratic formula, you'd have negative b, which would be 24, plus or minus the square root of 24 squared. Remember, I can drop the negative there because I'm squaring. Minus 4a, which is 4 times c, which is 36, all over 8. Well, we could continue this it's not as bad as you might think. But let's set that aside for now and think of another way we can do this. Let's instead see if there's any overlap here. These all seem divisible by 4, right? These all share a 4. So we can actually factor a 4 out. I don't know what's going on with my camera here. We can factor a 4 out. When we do, we're going to be left with an x squared. Okay. Then we'll be left with a 6, or minus 6x, and a plus 9. Okay. Now, when this happens, right, you can divide through by the 4 on both sides. And now you've simplified your problem down to this. X squared minus 6x plus 9 is equal to 0. Right? Much better than what we started with. In fact, no matter what equation you ever have, if you can factor something out of it, a constant, you can divide that through as long as you have 0 on the other side. It just gets rid of it. Okay? So that 4 is not actually going to affect what x equals for either of these. So now we can actually factor this. This is not all that bad. Hopefully, we want factors of 9 that sum up to be negative 6. So if I want a negative, we could try negative 3 and negative 3. Right? Negative 3 times negative 3 would be 9. Negative 3 minus 3 would be a negative 6. So we get a negative, or x minus 3 times x minus 3. Okay? And from here, there are two ways to think about this. Okay? We could either say, oh, from the zero product principle, I could say that x minus 3 is equal to 0, or x minus 3 is equal to 0, so x is equal to 3, or x is equal to 3. We don't have to list it twice in our solution set. We could just say, hey, the solution set is 3. Okay? That's one way to go about it. Or we could also say, well, hang on, x minus 3 times x minus 3, that's x minus 3 squared. I don't know why I put cubed there. Okay, so now I have some stuff squared is equal to a number. So we could use the square root property, which says that if I have some stuff squared is equal to a number, then that stuff is equal to plus or minus the square root of that. Well, the square root of 0 is just 0, so we have plus or minus 0. Whether you add or subtract 0, you get that x minus 3 is equal to 0. So x is equal to 3. And so you get the same solution set either way. And if you just wanted to brute force your way through it, if you actually calculate this out, what you're going to find is 24 squared, okay, is 576. Okay. And then this is 16 times 36 is also 576. Right, so this goes to 0, so we end up with 24 minus 8, which you guessed it is 3. Okay. So, no matter what method we chose to go about doing this problem, we ended up with 3. So in general, MyLabs Plus may tell you use this method, use that method, but it doesn't always have a way to know which method you actually used, right? So in general, I always suggest use the method you're most familiar with. Okay? Get the answer, whether that's by factoring if you can, quadratic formula if you don't know any other methods. Okay, the nice thing about the quadratic formula is it always works, but it might not always be the quickest or the nicest or prettiest way. Okay. Alright, so that was a rundown of quadratic equations. Hopefully you've seen most of this stuff before, and let me know if you've got any questions, and I will see you in the next one. Cheers.